Given that the log base a of x is 3, log base a of y is negative 4, and the log base a of z is 5, we're going to find the value of the log base a of the fifth root of x cubed, y to the fifth is z squared. Oh my gosh. Well, the first mistake students make is they put in 3 for x, negative 4 for y, and 5 for z. And you can't do that because I'm not saying x equals 3. I'm saying the log base a of x equals 3. So the process really is to break down this humongous logarithm into pieces so that we see the expression log base a of x, log base a of y, and log base a of z. So we are taking the fifth root of the argument. A fifth root is really what power? It's a 1/5 power. So thanks to the power rule, we can bring that 1/5 in front. And please note, never ever, at least in this class, will your base change. So make sure you always write an a. If you don't write the a, then you are saying log base 10, which we're not doing here. All right. So now we have a quotient in our argument of our logarithm. So that means we could break it up into the what of logs? Hopefully you said the difference of logs. But that 1/5 we pulled out needs to stay outside. And we're going to break this up into pieces, so we need some form of parenthesis. I wrote a bracket here because we're going to need a couple brackets, so it's good to differentiate between the two. So the quotient rule says it's the log base a in this case of the numerator minus the log base a of the denominator. Okay. That first logarithm has a product inside, so according to the product rule, we could write that as the what of logs. Very good. The sum of logs. Oh, what did I do? I forgot my log. Goodbye. I love you the most. Log base a of y to the fifth. That was my dog Marsh. He is taking a nap after chewing on a bone for 20 minutes. He has a tough life. All right. That 3, the 5, and the 2 exponents, that's another instance of the power rule. We can bring the 3, the 5, and the 2 in front of their respective logarithms. And I love how I'm telling you to do that, and then I forgot to bring the 2 in front. Oh my gosh. What are you going to do? I did it. Okay, now we can see our goal here. Here is the log base a of x. Here's the log base a of y. And here's the log base a of z. So now we can plug in the original numbers 3, -4, and +5 in for their respective places. So we get 1/5 times 3 times 3 plus 5 times -4 minus 2 times 5. Oh my gosh, what is that? 9 minus 20 minus 10. It's so much work. I'm too lazy to 9 minus 20 minus 10. Okay, that's -21. Then we have to multiply it by a fifth. So -21 fifths.